Hello, geometry, and welcome to the beginning of topic 3 on transformations. We are going to talk about lesson 3.1 and reflections. So reflections is the geometry word, right? The layman's term for reflection is a flip. So we're talking about some flips today, right? So we're going to look at these figures and how they flip, some rules and whatnot. Okay, so first of all, we're going to talk about some rigid motions. A rigid motion is a transformation that preserves length and angle measure. So a rigid motion preserves length and angle measure. So the question here is this transformation a rigid motion? Explain. Well, so you have the pre-image, that's the starting image, and then the image is, the final image. Well, if you look here, they're not exactly the same. Notice that the red image is shaped the same. So if you look at like the angle measures, like these two angles are the same, these two angles are the same, but obviously the side lengths of this pre-image are a lot longer than the red image. So we're going to say no. Okay? The reason is length was not preserved. The image is smaller than the pre-image. And again, the idea here is that these two figures cannot be different sizes to be rigid motion, and these two figures are different sizes. So if you think of rigid motions, preserving length means they're the same size. Preserving angle measure means they're the same shape. These two have the same shape but different size. Okay, so let's talk about the definition of a reflection. Okay, so there's some principles here to keep in mind when you do a reflection. So first of all, when you do a reflection, there needs to be some sort of a line of reflection that you're reflecting across. So in this case, M is the line of reflection. We're reflecting triangle ABC over top. Okay, so a couple of properties. First of all, if a point, so for instance, if A in this picture is on line M, then the point and its image are the same point. That means that A prime, the image, is the same as A, the pre-image, right? And it just stays right there. So that's if you're on the point or on the line. For every other point that's not on the line here, and I'll put stars, the line M is going to be the perpendicular bisector between the pre-image and the image. So if we look here, let's use B and B prime. So here's the segment connecting those two, the pre-image and the image. Notice that line M goes right through the middle of this segment. Notice the congruences, and it forms a right angle, perpendicular, right? That's a big idea, right? So M is the perpendicular bisector of segment B, B prime. Big idea. It's also the perpendicular bisector of segment C, C prime. Congruence, there's your right angle. Okay. When we're talking about a reflection of triangle ABC across line M, there is a shorthand we can use, and it's right here. Capital R for reflection, lowercase m for the line, and then the figure that you're reflecting. Right. And again, we talked about rigid motions. A reflection is a rigid motion. If you look here, between triangle ABC and triangle A prime, B prime, C prime, they're the same shape, they're the same size. One is just flipped compared to the other. Okay? All right, so here we go. It says, how can you reflect triangle FGH across line L? So we're going to use the exact definition and think of line L as the perpendicular bisector. Perpendicular bisector between our pre-image and our image. So let's start with H, because H is close. H is closest. So we have to go perpendicular to line L. So there we go. And now this distance from H to the line L has to be the same as the distance from line L to H prime. So let's just go out a little further. And there, I think they're congruent. That's where I think H prime is going to be. Now let's go to F. So again, we'll take F perpendicular to this line. Okay, there's my right angle. Here's my double marking. So now F prime is the same distance away going this way. Continue on that line. Sure. And there's F prime. Again, not going to be exact, we're hand drawing, but you get the picture. And then G is here, go perpendicular to line L. This is going to be my third length, so we'll go the same distance this way and put G prime there. And that is the same length. And I'll connect H prime, this is H prime, to F prime, to G prime, to H prime. And there we go. So this figure and this figure should look, I always like to shade in my final figure. They should look the same size and the same shape because the reflection preserves length and angle measure. All right, cool. All right, so that's not with the coordinate plane. So now let's move on to the coordinate plane. It says here's quadrilateral FGHJ with the coordinates above. Graph and label FGHJ and do the reflection across the x-axis. So we're going to do the reflection across the x-axis of FGHJ. And then we want to know what is the general rule for going across the x-axis. All right, so let's start with F at 0, 3, that's up 3. G at 2, 4. H at 4, 2. And J at negative 2, 0. Okay, so here's your figure. So now we're going to reflect it across the x-axis. This line is the x-axis. So since we're reflecting across the x-axis, we're going to reflect down across, right? So this is very simple as counting, okay? Now, first off, J prime is going to just be J, because J is on there, so that's J prime. F, so we're going to count down 1, 2, 3. So now count down 1, 2, 3, and there's F prime. G, count down 1, 2, 3, 4. Now count down 4 more. 1, 2, 3, 4. There's G prime. And H is 1, 2 away, so count 1, 2. There is H prime. And there we go. Let's connect those 4 points. And this is going to be our final figure. So what's the rule, right? Well, if you take a look here, let's look at F, right? F's bad because that is 0. Let's look at G. G's coordinates were 2, 4. Well, now what are G prime's coordinates? G prime's coordinates are 2, negative 4. So what happened is the y turned opposite of what it was. Notice I didn't say negative because if it was negative, it would turn positive, opposite of what it was. So here is our rule for reflection across the x-axis. If we're going to reflect across the x-axis, our point xy is going to become x the same, but y opposite. And there's our rule. And again, you need to think of this negative y as the opposite of y, right? Opposite of y. Okay, so let's do something similar across the y-axis in the next example. Okay, so it looks the same, but it's part B. Same figure, but now we want to reflect it across the y-axis and come up with the general rule. So maybe you have an idea already. Okay, so we're going to take the original figure 0, 3, that's F, 2, 4, that's G, 4, 2, that's H, and negative 2, 0, that's J. We're going to connect it. Okay, and now this time we're going to reflect across the y-axis, which is this guy going up and down. So because we're going across the y-axis and F is on the y-axis, F and F prime will be the same exact point. And now we're going to count left and right. So if I go G, G goes 2 left, so go 2 more to the left. There's G prime. H, go 1, 2, 3, 4 to the left. Go 1, 2, 3, 4 more. There's H prime. And J, go 1, 2 to the right, so go 2 more to the right, and there's J prime. And we're going to connect those 4 points. And there's my new figure. So now again, let's compare G's coordinates to get the idea. So G was at 2, 4. Now G prime is at negative 2, 4. So the rule this time is if I have a point x, y, and I'm going across the y-axis, now my x turns opposite and my y stays the same. And there's your rule for going across the y-axis. And again, that negative in front of the x is considered the opposite of x. Okay, so there's the first video. The second video is coming up right next.